Hello, welcome to this fifth lecture in the series of Introduction to GIS. If you recall yesterday, we have discussed various types of vector data as well as various types of raster data and their comparisons, advantages and disadvantages. One more type of data which is handled in GIS is TIN, that is triangulated irregular network. And in this particular lecture we will be focusing mainly on this TIN data model, and we will try to see the advantages and disadvantages in comparison to raster data. TIN is also in previous lecture I have mentioned that TIN neither is vector nor raster, but in some literature you may find that they have put along with vector, in some literature they have put along with raster. So let's keep it as a completely separate. And TIN, you know that raster is having a rectangular grid or a square shaped grid, but the unit is there is a square all the time. In case of TIN, it is a triangulated irregular network. That means there are a series of triangles of different shape and sizes, and this shape and size is decided based on a theorem or a concept which was given by Delaunay triangulation, which we will discuss just little later. So sometimes what happens that when terrain is having lot of undulation, a natural terrain having lot of undulation, like for example Himalayan terrain, it is having very high ruggedness. There suddenly you will find a hill and then the valleys, ridges and valleys, and because of that your regular rectangular grid, that means the raster, cannot really represent the whole complete roughness of the terrain, and therefore a different kind of model is required to represent such terrain conditions. For a plain area like Indo-Gangetic plain, which is a alluvial plain, very flat area, where you can represent even using simple contours, that means vectors, using polylines, or even raster, or with the TIN as well. But the same models cannot be applied so easily in case of a rugged terrain like Himalaya. Contours, if you see a 50,000 scale topo sheet in which even if contours are having 100-meter intervals, they are so close because the ruggedness, the changes in elevation in a small horizontal distance is very high, and therefore you need to have a different kind of model, a data representation by which you can truly represent the terrain or near natural conditions. So the complexity of relief cannot be really represented by regular grid like raster data. So this concept of terrain has come. Now obviously each and every data model, whether it's a vector data, raster data or TIN, all are having their own advantages and disadvantages. Initially you can also realize that if suppose there is a point data and which I want to, this is a discrete, I want to make a continuous data, so I can use as a regular grid. That means I can create through interpolation techniques, which we will discuss sometime later in this course, and can create a grid using these points as observation points. Same time, using the same observation points, you can also create a TIN model where you are seeing different shape and sizes of triangles which are in a complete network, and this network is irregular, but it is based on certain concept which we will discuss just after this. The other important thing that on where you do not have any observations, that is the limitation in case of TIN. But in case of raster, between two observations interpolation will be done, but beyond an observation then extrapolation is done, and therefore you achieve a completely rectangular or a square shaped raster. But in case of TIN, that kind of thing cannot be achieved. So let's look the definition that the surface representation, terrain surface like a Himalayan rugged terrain, can be derived from the irregularly spaced points and break line features, and each sample point has an x and y coordinate, and then z value or the surface value. So you are having x, y, z together with this one. Now as we see that a tin represents a surface, a terrain surface which is a set of contiguous and non-overlapping triangles. No triangle will overlap to another one, neighboring triangle. This is the same condition almost in case of raster data, but initially when these satellite data or image data, which is also a raster data, when it is started acquiring by the Landsat 1 through the sensor which is MSS, at that time there were overlapping pixels, that means overlapping cells of a grid, and it was, instead of saying pixel, we used to call as pixel, but later on this problem in later sensors was resolved, and now each pixel is representing unique area of the earth. So here in this case, in case of tin, there is no overlapping triangles. Each triangle is representing a facet that we will see. Within each triangle the surface is represented by a plane, and the triangles are made from a set of points called mass points. The input, the same input, that is the discrete data, that is the point, the simple vector entity, can be used using interpolation to create a grid, raster. Whereas the same set of points, discrete points, can also be used to create a tin surface. This is the basis of tin, that Delaunay, who was a mathematician, Russian mathematician, Boris Delaunay, in 1934 he gave the concept, and which that if a circle is drawn through 3 points, then that it should touch these points, but no other point should fall in it. So see that it says that the satisfy the requirement that a circle drawn through the 3 points, 3 nodes of a triangle will contain no other node. So you this, based on this algorithm, we keep creating triangles till we reach to this condition, and once this is satisfied, then that triangle for that particular area using 3 points is finalized, and likewise for entire input points a triangulated irregular network is created. So this is the basis of that when a circle is drawn through the 3 nodes here in this example of this yellow colored triangle, then within that triangle no other node will come. So only 3 nodes can be there, not beyond. If there would have been one more or 2 nodes, then smaller sizes triangles will be prepared. So the tin, as mentioned, neither vector nor raster, or may not be exactly hybrid model as well. So tin, let's consider tin as a complete separate kind of data representation model, especially suited for highly rugged terrain like Himalaya. Now tin, as you know that vector, how a vector is stored in a system or vector is handled by computer is altogether different. Similarly, raster or grid are handled based on the matrix concept of mathematics, whereas the tin, again it is stored in tabular form, which we will see. 4 tables are created for each tin. One table is called node table, the other which is containing the list of each triangle and its defining nodes. We will see example very soon. Then we are having edge table. Edge table lists the 3 adjacent triangles for each facet. The neighborhood operation, as also discussed in previous class, that these have to be kept in the system. GIS is one of the basis of GIS is keeping information about neighborhood, and XY coordinate table, that means the coordinate have to be also stored, all those points which have gone to create the tin, and which are node coordinates, and Z table, which is your height value stored in case of elevation, that becomes your Z. It may be some other value, no problem. So that value will go in the Z table. So let's see the real example, that there are nodes 1, 2, 3 and up to 11. So there is a node table, and that is storing the number of nodes which are making a particular triangle. So if we take example of A, that triangle A is made from node 1, 6 and 7. node, triangle A is made from 1, 6, 7 and so on and so forth. Similarly, the next table is the edge table, which stores the adjacent neighborhood operations. So, if we keep the same example of triangle A, then neighborhood triangles here B and K. Now, important thing here is to note that outside the other side, the third side of triangle A, no triangle exists and therefore no information can be stored. Now, as mentioned earlier, in case of raster, when we use point data to create a raster surface through interpolation, between two observations interpolation is done. Beyond one observation, when you don't have other observation, then extrapolation is done. In case of tin, such things cannot happen. So that at the margins of your data, the extent of your data, you don't have any other triangle because you don't have any observation. Otherwise, this cannot satisfy the condition given by Delaunay. And then xy coordinates are also stored. So, say for node 1, then x1, y1 and likewise for all these, in this example 11 nodes are there. So, all the data will be stored about their coordinates. And then last one is the z coordinate, that is maybe height or maybe some other concentration value. So, for node 1 that z1, node 2 z2 and so on and so forth. And there is no gap. So, it is a continuous mass of triangles. Triangles vary in size based on roughness and complexity of terrain. See the size, that is why irregular network, triangulated irregular network. So, there are the unit here, like in raster unit is a square, here the unit is triangle. But in raster the size of unit throughout a raster data is same. If it is a 10 by, it is representing say 10 meter by 10 meter of the ground, then throughout the data it is 10 meter by 10 meter. But in case of triangle, the unit is of course triangle, but the size and shape of triangles keep varying. And this variation will come because of the roughness or complexity of the terrain. So, let me give you one more example, the same example again, that if there is a Himalayan terrain, then roughness is very high, and wherever roughness is there, smaller triangles will be formed. Whereas in case of a flat terrain like Indo-Gangetic plain, when roughness is very low, is almost flat terrain, then large triangles will be formed. We will see through some real examples as well. So this picture will come very clear about large versus small triangles. Let's take the real example. Here the data for an area is represented through contours. That is a discrete representation through your vector data. But if I have to represent the same terrain through a trim model, then this is how it will appear. And what you see that wherever we are seeing less concentration of contours, that means the contour lines are sparse at a little larger distance compared to other places, then in this part you are seeing the large triangles. Whereas where contours are very close, that means the surface roughness is very high, ruggedness is very high, and therefore smaller triangles are made. So that's the beauty of tin, that it is adaptable to surface roughness. Comparison to raster, it is not adaptable. It is fixed. For throughout that data, the size of a cell of a grid is fixed. But here, the size of a triangle varies, including the shape of the triangle, as you can see in this example. Another real example, that using point data, a surface through interpolation techniques have been created, and then later on, in order to make it a little closer to the tin, shaded relief model has been also prepared for that. So this is the representation at a particular resolution, and this is the representation of the same terrain using the same point data set through tin, and this is how it looks. So if you see or zoom closely, you would find that there are small large triangles depending on the surface roughness, and it's a continuous mass, and this is how the terrain is represented. Now this is another important thing is, when you create tin through using any GIS software, you would see that two more byproducts are generated simultaneously. One is a slope map and another one is aspect map. And the third one you can also say about this shade relief model. In case of raster, each these products have to be created. So in tin, these are created automatically. They looks better. The tin model looks better, but as I have mentioned, if in this particular example the edge problem is not shown, but in real situation the edge problem will always be there. At the boundary you are having problems about the data. Now, as let's look the advantages and disadvantages associated with tin model, and that because it is adaptable and therefore it can represent the complex relief roughness or terrain roughness in a very nicely manner compared to even your vector data or raster data. Secondly, I have already mentioned that the terrain parameters like slope and aspect are calculated for each triangle and is stored as a attribute of the facet, that means the triangle, and a more detailed representation for higher density of data point. If your observations are a lot for a small area, that means the data points are very high, then you can have much better representation. Well, that this kind of condition is also true in case of raster, but there the size of the cell will not change. Here the size of the triangle and shape of the triangle will change if there is a variability in the observation. That means if there is a lot of changes in a small area, or surface roughness can be represented nicely. Another point is the breakpoint features more accurate. That means sometimes you are having ridges or valleys which are the sharp change, elevation changes features, and these two can be represented in a much better fashion using tin data model rather than raster. Now disadvantages, one disadvantage about the edge problem or boundary problem I have already discussed. So it takes more time for processing to generate tin file. So if you take the same set of points and create a raster using one of the available interpolation technique, you may not take that much time as creating tin. So tin takes more time because lot many things have to be calculated and organized in case of tin. And as I have already mentioned that errors along edges often need correction. This problem is sometimes it later on in GIS operations it becomes little difficult or big. So one has to decide whether he is okay with whatever the tin is giving, or if it is on the edges, if there is a problem, then you will have difficulties with the tin. Now there are two more things I would like to discuss here. Like in case of raster, you can extract raster. You can extract or make a subset of raster. But in case of tin, the clip or subset cannot be achieved. For example, if you are having a raster data like this and I want to extract a part of this raster, say below this polygon, it is very easy in GIS operations that I can extract this raster. But remember fundamentally what I have said about raster, that raster will store its data in the computer either in rectangular form or square shape. So how it will do in this case? Very simple. When I extract this one, it will keep the real data for this real data, but here for outside it will keep the no data. And no data that doesn't mean zero value. No data means some value which will be declared to the computer that this is my no data value. For example, it can be say a value like -99999. Now why these kind of values? Because most of the time the digital elevation, in case of digital elevation models, we know that we cannot have on any surface of the earth a point which is having such depth or some plus values. So therefore it is declared to the system that this is no data value, and that means whenever I am doing any processing on this data set, then I don't want to include the outside area. I want to include the area which I have extracted. Now if I am having a tin model, as we have been discussing, so in case of tin, there would be edges. There would be edges in case of tin, and these I cannot use any model. I cannot use any extraction tool to cut here, because what would happen, think what would happen in case of these areas. Similarly, the areas which are going in another triangle, because fundamentally the unit here has to be a triangle, and that is why jokingly it is said that there is no scissor which can cut this tin, the tin in the GIS, whereas the scissor exists, software tools exist to cut a raster, but software tools do not exist because fundamentally they are not supported to cut a tin or extract a subset of the tin. So this is another limitation of a tin, and all this limitation is coming just because of the errors along the edges. Errors, the boundary problem with the tin is quite big sometimes. Another thing is that a lot of analytical tools which we will be seeing in later lectures, that they assume that the data, input data is coming in form of raster. Now if I have created tin, after some time I would realize that this tin is giving problem to me during my advanced analysis. So therefore there are tools are available to convert your tin into raster. Now question is, ultimately if I have to only convert the tin to raster, then why I would make in between tin? So that depends on your project requirements. If your project requires only up to the tin and you can deliver the things as per derived using the tin, it's fine. But if you want to use that tin further along with the raster data, then you have to convert into raster. So this is another limitation with the tin. Now we have already completed sort of thing, but for comprehensiveness and completeness we will just go one by one. That the advantages with tin is ability to describe surface at a different level of resolution. Resolution is not fixed here because the size of the triangle is not fixed, and it is there is no redundancy in case of tin, but in case of raster that it stores and it is easy to store and manipulate, because concept wise raster is the most easy data format, even easier than your vector, and it is easy integration with other raster data sets, for example satellite images, which are the very big source of data input in modern days GIS, and then a smoother, more natural appearance of derived terrain features. Looks in case of raster may not be in case of tin, and in many cases disadvantage, many cases requires visual inspection and manual control of the network. Sometimes you get some problems and then these problems cannot be automatically solved, so manual intervention, human interventions are required at this stage. But in case of raster such problems may not come. Inability to use various grid sizes to reflect, that means if I want to see the high complexity of relief, I have to adopt for higher and higher spatial resolution. So these are the advantages and disadvantages associated with tin and raster. Let me take a few more examples and the comparison sort of thing, that if I don't use any break lines, then the data can be represented in tin in this form, whereas DEM means the raster, it is in this form. But when I use the soft break lines, then I will represent the tin like this and my terrain like this, and this is a 3D view for all three types of data generation. And the third example is when I am using hard break lines. I will elaborate on this about the hard break lines, soft break lines and no break lines. Break lines can be ridges, can be valleys, sharp valleys, or can be geological structures. So when these structures are very prominent and having complete influence or control over the terrain, then we will go for hard break line options while creating a tin or creating a raster. When we are not sure that how much influence they will have, they might have influence, may not have influence, that kind of thing, then we go for soft break lines, generally in the terrain which is not rugged as like Himalaya. So if it is terrain is smooth terrain, undulations are there but very smooth, then we will not go for hard break lines options, we should go for soft break line options. And when we don't know, we don't have any input about the break lines, then either you go and collect it. If it is not possible, then you have to live without no break lines. And as you can see that the prominence, because of the choosing hard break line, the terrain looks altogether different than the terrain without break lines. So this has to be, these are the options while creating tin or raster about the break lines. But the knowledge of the break line has to be there, one, and this input will come as a vector layer, as a vector polyline layer. So another very, tin has got wide applications. Almost all nowadays these animations which we are seeing on internet or through computer games and other things, they all are using this tin data model, and then top of that they are warping with some color, image or pattern. So digital elevation model is one of the good applications of tin, which represents your terrain and can be used for few more analysis like cut and fill and other things. Surface reconstructions, especially for three-dimensional surfaces, it has got in applications in industries, and apart from terrain, it has got producing animations, movies and other things. I will show you some examples. Like here, if I have to represent an animal, then I can use a tin to represent a 3D surface. Instead, if I go for raster representation, I may not represent that animal so accurately as using tin. That is why in most of the animations, people have adopted tin rather than raster. And the animators use triangulations to create models of characters, as you can see for these dinosaurs, and these models help them map the movements by computers, because when these animated animals moves, it is much easier to control through these tin models rather than any other model. So that is why it is preferred by animators to use tin. And once you fill these triangles with some color or shade or skin color, roughness, then these animals looks real one. So this part is not as completed, the rest is completed, so looks much real one. So thank you very much for this.